Let's do the same 4 steps. So my first step is let's figure out what all these masses are here. Okay, so 320 kilogram rocket, our initial mass, right? I'm assuming that that's everything. That's the total mass of the rocket. That's what I'll always tell you. So 320 is our initial mass. That's the total mass of the rocket. Our final mass is not 280. I believe it's going to be 320 minus 280. I think that's 40, right? Okay, so our final mass is 40 kilograms, right? The mass of the fuel is 280 kilograms. Okay, so let's square that away. This will be the mass to begin with, the mass to end with. That's the mass of the fuel, right? Our next step is to figure out the thrust, right? So force times time is mass change in velocity, right? So let's see, force times 31 equals the mass. Remember, this has to be the mass of the fuel. So 280 times our exhaust velocity is 920. Right? So now let's solve for the force. The force is equal to divided by 31. The force is 8309 point, I'll say 7. That ought to be good enough. Newtons, right? So that is my second step, right? My third step and fourth step are to find the initial and final accelerations of this, right? All right, here we go. Okay, so to begin with, we've got the rocket. Now, if your rocket doesn't look as good as my rocket, well, you know, remember, I'm a professional physics teacher. All right, so 8309.7 is that's a 9. 8309.7, right? And this is a 320 kilogram rocket. So 320 times 9.8 is 3136. So this downward force is 3136 newtons, right? And now we're all set. Now we can set up a expression. We can go 8309.7. That's our thrust, right? That's the upward force minus the force of gravity equals 320 times A, right? And now we just do the maths. So I'm going to go this guy minus this guy. I get 5173 equals 320A. And now divide by 320. And I get 16.2 meters per second squared. That's our initial acceleration, right? And then finally, let's draw a picture of this rocket. In the end, it's got a force. The force is still 8309.7 newtons up because the rocket will assume the thrust doesn't change. But in the end, we only have 40 kilograms. Right? This was kilograms. I like to write it this way because it seems clear to me. 40 times 9.8. So that's 392. So 40 times 9.8 is 392 newtons. And again, we're going to set up the same expression, right? 8309.7 minus 392 equals 40A. Notice I got the mass there. That's the mass. Here I've got the mass. That's the mass, right? It's tricky. All right, so here we go. when I do this, 8309.7, I'm finding it. I'm too lazy to type it in. I've got it. Okay. Minus 392. I get 7917. 0.7 is 40A, right? And then I'm going to divide by 40. And I get 198 roughly. Ta-da.